Okay, we're live. Hello all, hello world. This is day 215 of studying compilers every day until I land a compiler role. Last time we finished implementing like deref. This time, our plan originally was to implement arrays, but I kind of don't want to do that right now, and I kind of want to do more middle end stuff, so we're just gonna do more middle end stuff. Yeah. So let's put this back in here. What's up, Izarth? Good to see you. Okay, let's clean up our like little stack first of all, or I guess our like big pile of stuff. So types. So we have like add more primitives. And we want to do this stuff. Oh, we want to do that. That's the wrong way. Yeah, that makes sense. Let's also put this in here. What loops? Do you support type def? Not yet. It shouldn't be that hard in theory. I'm just like really lazy and don't want to do it. And there's also just like a lot more other interesting stuff to add rather than just that. So we're not doing that for now. Let's see. What else do we want to throw into here? We're gonna add arrays into here. Okay. This is backend stuff. We don't care about a lot right now. For now, let's look at middle end passes. So, yeah, I'm not sure what specifically I want to implement here. Let's pull up the Mushnik book. It's been a second since I've opened it. What's up, Max? Good to see you. Holy shit. Yeah, type def's a mess. Anything even remotely like meta programming-y is really annoying. Oh my god, why am I using Acrobat? Can I just open this in Chrome actually? Or Firefox? Okay, where does this live? Books. Open with Firefox. Okay, much better. I don't care if this is full blind. This is more bearable. So let's get rid of that. Yeah. Okay, there we go. Let's see, what do I want to look at? Early optimizations. SROA, this could be interesting. I remember reading about this. I never actually like figured out what it actually is, so that could be an interesting thing to look at. Maybe I do value numbering. I think that might actually be the most interesting. Maybe we should do that. That and like copy propagation. Yeah, I guess that could be interesting. I think SSA makes this pretty light though. Oh, and then I also read about this. Yeah, typedef does it does make a mess of that. Although like there's some instances where like in this code base it like made sense. What's a good example? Like in coloring, I think. I guess we use like using, but like it's like basically the same thing. It's just the C++ modern way of doing it. Just like shortening things and like making things. Sometimes it makes it more readable. Other times it does not. Very frequently it does not. So I'm relatively conservative with it. Yeah. Okay, maybe we should just go top down through early optimizations. I think this is probably the best way to go about this. Yeah, so we did constant folding before. And that lives all in transform inst combine. I think we only did some of it though. I think we could be more aggressive with it, but this is like probably fine, at least as a start. Yeah, these types are awful, but we'll worry about that some other time. Yeah, when we implement more types, we will go back through this. Yeah. Maybe there is some weird pointer arithmetic stuff now that I think about it. That might make a mess. We should probably look back through this, but I really don't want to right now. So we're gonna save this for like another stream where I'm like really bored and don't want to do anything interesting. Okay. So SROA. I've read up about this. I don't know what it is. Relatively few, really. This is not doing a great job of explaining it to me. This is not what I'm looking up. Yeah. Stack out. Oh, I see. Okay. So it's just like decomposing objects, I think. Right? Grokpedia. Okay, I'm very curious. What is Grokpedia? Ugh. Fact checked by Grok. What are we doing? I'm not reading this slop. Is there like a better place to look for this? Surely there's like... Surely the Wikipedia page isn't that bad. Escape analysis. Oh, I think it's this, yeah. Okay, yeah. So it is like very conceptually simple, it seems like. So if we have like, I guess if you understand aggregate components as like just objects, I guess, objects, classes, etc. I think that kind of makes it make sense. This is just like very awkwardly worded because like this is an old textbook, so yeah. So they have simple scalar values such that both the components and okay, that makes sense. Okay, so we just take them out of memory pretty much. The funny thing is we can't do this right now because we don't have objects or like we don't even have much like that can fit in memory. Like we can just take stuff out of memory, but like I think that's not really interesting here. We kind of already do that in some sense. Yeah, so let's just skip this for now, but we might put a pin in it and come back to it. Okay. Algebraic simplifications and reassociation. What's up, Niraj? Good to see you. We're back in the textbook. What do you mean already? It's been a long time, I feel like. Okay, wait. This seems interesting. Nah, you're definitely around for like day 200-ish. And I've low-key been slacking, so it's been like a month since then almost. It's been a while actually. Wow. Yeah, just like a lot of random stuff has taken up time. Okay. So, reassociation, and then algebraic simplification. I guess this kind of all makes sense. We just do more. This is like kind of in the inst combine category, so this might be an interesting next one to work on. Okay. Combining a binary operator with an operand. What? That is identity. Okay. So like ×1 or like +0. That's probably good to do. Yeah. Okay. So let's see. How do we do this? So okay. So we have like this lambda, this giant fat lambda for that. Let's make another one, and this will be reassociate, I guess. or I guess constant we could just call it reassociate. I think that's probably reasonable enough. Try reassociate. We'll do that. Oh, a little funny thing here. Real quick, let's return false. Okay, so the reason we have these cling format guards, if we delete them, it turns into a straight line, and that's really annoying for maintenance because then I can't like copy paste easily or like reorder these easily. So that's the reason those are there. I just like having it like that because, well, I'm cringe. Maybe I should like try to pull these functions out somehow, but I think, I don't know. This is like a mess to maintain already, so if there's a better way to do it. If false, yeah, because then we don't have to have something on this line. And then all of these can start with ors. It's very nice. But I mean, the trade-off is this looks ugly to some people. Some people don't like it. I think it's great. But yeah. Yeah. How's it going, Aiden? I imagine everything's like long submitted now for the competition. Can you not just format off above? What do you mean? Oh, like by getting rid of false? Cause I like having or prepended to everything. So I'd have to like delete this or. Yeah. Anyway, silly little trick. Okay. Let's look through this pile. I think this is somewhat exhaustive. Yeah, I don't think empty ore is the thing in here. Yeah, I guess that's like a reasonable final state to be at. It seems like you kind of got all of the, not even free lunch, all of the subsidized lunch that you could. Okay, so let's do op with 0 and multiply by 1 or divide by 1. I mean, like, yeah, you put up good numbers. It was really cool to listen to, at least, and like sort of follow. Bio final, fuck. I mean, like, who gave about bio? The real class is 322. Hackathons for the food? That's so real. Yeah, our school hosts a hackathon every year, and like, low-key, half of the people just go for the food. I kept trying to make real things, and I was like, I got like engagement baited into making actual things and like ruining a night of my life. Instead of just like going for the food. I would have been much smarter. Okay, let's make a list of things. Okay, so let's see, what do we want here? Okay, we'll do that. So let's see, we want reassociate. We'll do that. We could throw value numbering in here. Was it like Yamato LaTeX? It was like some Lisp-like language that I made up on the fly. But I really should have just used JSON. That was like really stupid. But yeah, then it was like, you like put your resume in it, you like write your resume in some like resume language. Yeah. This chud resume lang thing. Yeah. And then like you have like a LaTeX template and you have like a TypeScript template, and then you can like generate both at the same time. It was like cool until like I thought about it and I was like, why would I ever use this? And it was no longer cool. I also like low-key didn't do anything interesting with that. It was all just plumbing work. Okay, value numbering. Let's add that here. Copy propagation. Variadic templates. They could be arranged. SCCP. I never like properly learned what this was, so all I know is that it's cool. Where does it explain the SC? Wait, you could actually explain it to me. Yeah, that's crazy. Wait, you should take over my stream series, Loki. Oh, I don't want to read this. Okay, so this does not help me. So where does sparse come in? Nah, Loki, like, you've implemented more stuff in the middle end than I have, which is like really funny to think about. Okay, wait, sparse. Okay. Okay. There's the word conditional. There's the word sparse. There's also the word conditional here. Sparse because of how it seeds. I see. More efficient, sure. I see. Okay. That kind of... I guess that sounds reasonable enough. Okay, so we do SSA. But not SSA. Or like a very restrictive SSA. How does that work? Is it just like the instruction flow graph then? That seems a little ridiculous. I guess either we convert it to that or we just only fire it on those then. Use staff, def use, got it. Okay, iterated dominance frontiers, sure. Minimal SSA, my beloved. One instruction per node. Okay, sure. That seems fair. Then we perform a symbolic execution of the program. What'd that mean? Okay, we'll figure this out once we get there. I'll add it to the list. Okay, and then wrap up. Okay. Oh, wait. Okay, sure. More sophisticated. Symbolic execution. Okay. Well, I should have just read this page in hindsight. Okay, well, anyways. Yeah, let's do the, like, reassociation, algebraic simplifications for now. That's, like, pretty light. I think it'll add some degree of performance bump. I don't think there's a lot that will change, because a lot of the stuff just gets constant folded anyway. But it might be interesting. Yeah, value numbering will also be good once I get there. Copy prop is like fine. Yeah, okay. Okay, and then there's the giant chud table. Okay, I think this is a good enough list for now then. Let's work on good old simplify reassociate. Okay. Oh, I can use J and K in this. That's very nice. I forgot about that. Let's see, where am I? Up more? We're in value numbering. Okay, here we are. Maybe I need to zoom out a little then to fit. Okay, perfect. Alright, so I plus 0, 0 plus I. That's not I. We want I minus 0. I'll try to focus for 30 minutes over the next 4 hours. Good luck, bro. Thanks for stopping by. If you can't, then I don't know. Make it happen. I know you can make it happen. One times I. Okay, this is like, I should just be implementing this. I don't know why I'm like listing all this out. Unary operators. Yeah, there's so much to do. Or it'd be the other end, because bitwise and would not work. Right? Wait. Oh, I see. Yeah. Okay. Yeah. Had to think that through, yeah. Oh, what's up, Arish? Delegation? I guess it is, yeah. I've been kind of inconsistent recently, but I guess broadly speaking, you could say that. Yeah, I appreciate it. The unary operator ones are interesting because they also might do like a typecast. It's like if you do like even just like plus, like, I guess we could check for that. Yeah, we're gonna need to rewrite all of this to be type cognizant as well, now that I think about it. What language are you making your compiler in? The compiler translates C to x86 64, but the language I'm writing in is C++. Loop the I 5 times and add an if condition? What'd that mean? Okay, we do just need to rewrite a lot of this, which is very unfortunate. Because we do have to worry about types all of a sudden. We should just implement types. Everything just comes back to adding types, which really sucks, because I don't want to do that. I just want to optimize. Okay. Let's see. Let's do that. Alright. Let's do that. And then yeah, let's just get left and right. Oh, I see. Okay. We could probably combine these actually in some way. Right now we'll just do it like this to be readable. So we want to do that. We want to do that. Okay, so then and then I guess we could do like I guess otherwise it's a value, right? So we're gonna do some really heinous shit. So if we want like XNOR as opposed to XOR. So let's do not left literal XOR right literal. So we want them to be different. Oh my god, I can't type. So I'm gonna do that, I think. Oh wait, we can just do that. Right? Bull. Okay. That's a very ugly line of code. I do not like this. I think we did something like this before. It was in tree tiling. So let's go there real quick. I want to see what I did. It was really heinous. So let's look for XOR. Oh, we got rid of XOR. What the hell? It's somewhere here. Right? It's one of these giant tiles. Yeah, it was here. It was something here. It was like this thing. Ugh, that's awful. Maybe we will just do the double XOR. Or like the double not. So, let's do not right literal. Okay, we'll leave it at that for now before I go insane. Or maybe we could do all of the casting at the top here. XORing pointer? Yes. Or I'm XNORing pointer, but it doesn't take pointer type. So let's just also get the left, or I guess it's value by default anyway, so that's probably fine. Right. I think that's probably fine. Otherwise it's just like a register, which is fine. Yes, we have that. Bin, op, get left. And then we can also just like use that in here. And then we can do that. And then make that right. Like that. Oh, the formatter. God damn it. Okay, that's fine. We'll deal with that. Whatever. Instead of doing this then, we can XOR. Actually, that is still just the cleanest way to do it for now. Okay. So now we can go back up to this little pile, I think. Okay, so left, let's go case by case. So we have left, and we have right, so literal. We need to do that so we don't access null pointer. Get value. Yeah, so if that's 0, Oh, we should get op as well. Define op. Let's move that up here. Nice. Okay, so let's... We'll do a couple of these. So let's do it the other way now. So right and left literal. And... Or we want not left literal. I guess we've already filtered it out, right? So that should be fine, actually. So we should just be able to do this. Or we could do more nesting, actually. That could be funny. Yeah, let's do more nesting. Let's do that. Let's get value. And then we want left val here. Can we just switch block on here? Let's write if statements for now, and then if we can simplify it, as in we don't make any like intermediate variables, which I think we might make. So I don't think we can, but we can give this a try, I think. Okay, so right val equals 0. Yeah, there's not gonna be a pretty way to do this, unfortunately. But that's like whatever. Yeah, I think that's all we need in here at least. And then we can... There's gotta be a better way to do this. We could fire some checks only on... Some checks only fire... Let's reorder this to make it more clear. Okay, yeah, so there's extra ones on right literal. So we should do it like that, I think. Yeah, that might... I think this might make it a little bit more maintainable. Yeah. And then we can have some that just fire generically, I think. We'll do it that way. And at the bottom here, return false. So in here we want constant equals what? Yeah, we'll do it like this. Do you do canonicalization? Canonicalization first? Not really. I think this is supposed to be kind of like our canonicalized pass in some capacity as well. Maybe I should just make a canonicalized pass. That might be smart. But it's like really annoying to do, so I don't know. Yeah, what is the order LLVM does canonicalize? Yeah, so even like inst combine itself is a canonicalized pass. Well, that's not what I'm looking for. Grr. Yeah, none of this is really helpful, I guess, which is like fair. Yeah, I'm just gonna use inst combine as the canonicalized pass, I guess, and it's gonna be fine. Maybe I should just rename it canonicalize. That might make sense. Anyway. So we have constant, and then auto, I guess, variable, or just var. So we want left literal, then it's right. And we can do that. Okay. Yeah. So here, oh man. So this is where some of the cases come in. So that's op. I guess we want to check constant again, right? Maybe we could order it like this. We can do something. Yeah, so we can do that. Okay. So if it's 0 and what do we want again? Op. Maybe we do want a switch block for this. Okay, so what can this be? What is it called again? MR binary op? Yeah. I think there is a place we can just yoink all of these. I'm fairly confident there is. I think it's here? Yeah. So let's just yoink that, and we're fine. And then we can comb through this. Okay. So if right literal, then that means we care about this. We care about divide. Do we care about end? Or is this like a one-way thing? I guess it's not. Or is also not. XOR is not. And then shift, I think we don't care about for the most part. Or no, these we do care about here. Right, because we want to shift by 0 maybe. Yeah, okay. We'll do those. Okay. Oh my god. Okay. So subtract, we want subtract 0. Shift, we want shift 0. Divide, we want divide by 1. Okay, so we want left, So if left literal, or no, right literal. So that's one. Then, what do we even do with this then? Ah, MIR, god damn it. Okay. We'll just... We also need this here. This should equal 0. Okay, then we want... What do we put here? I guess how would we combine this? So we just take left and then replace all uses? We have like a replace uses visitor, yeah. Or we need to make that. Ah. Okay, so we oh man, that's so annoying. Okay, I guess we can make this regardless in here. And instead of that, we want to replace, so we want to replace spin up with var, I believe. That's how we're doing this. And then we can do RUV, visit. Oh. Okay, we're just gonna yoink that, I guess. So we'll do that. We'll, this is getting really nested. Maybe we should just put this up front, actually. This might be a good idea. Okay. What's up, Ahmed? And also, what's up, Jason? Are you actively interviewing or just building skills? A little bit of both. This upcoming summer is an internship summer, so I've kind of been chilling on, like, recruiting. Now I've been focusing mostly on skills in the past, like, year or so, but, well, we're getting to the summer, which means I gotta start recruiting again, so it'll transition back towards being more of both again. Yeah, I will be recruiting for full-time this upcoming recruiting cycle, so I think that is kind of where the series actually, like, gets its grounding more formally. Yeah, let's yoink this. Yeah, we can do that. This is kind of ugly, but it's fine. Yeah, okay, we can do that. Yeah, okay. This might also be slow, but like it's fine. we will deal with it. Okay, so now we can have more fun here. So now we can use the rest of these, I think. But in here. So instead of subtract, add, we can get rid of shift. This should be multiply. Yeah, we can get rid of the breaks actually for return true, now that I think about it. Okay. Let's see. So multiply by 1. We also have the other operators. Oh, we need to check that. Okay, we should probably drop this here then as well. Oh, wait, I see. We need braces around this as well. So we do need the break there. Let's yoink that again. Or like that. And then we can just do this, but we'll make this 1 again. Like that. Okay. To do. To do. Sure. Oh, that's ore? That's supposed to be ore? I guess that makes sense, yeah. But why do we use and not... Anyway. Okay, so if the length is... Oh, wait, that's cool. I forgot about that. X86, or is there like C shift past register? Yeah, okay, this is undefined. This was like a really annoying source of undefined behavior. Also, negative is interesting. We could just like do whatever out of it. Yeah, there's like this bit masking thing, which is crazy. I forgot about that. God damn it. Okay. Alright, well, we'll just not worry about that case, but I think we can at least fold out the 0, right? So past the, yeah, we'll do that. Okay. Or I guess we could probably bundle all that in here. But that's fine. This is all just gonna be really ugly. Okay. So add, multiply. And with -1. And then, or with 0. Yeah, we should do that. So this should also be or. And then we should yoink that. What is get value? What type is get value again? It's a, oh, it's a long. Wait, it's signed? Wait, hell yeah. Okay, we can do that then. Nice. Is there anything else I'm forgetting here? Those are all handled. Yeah, okay, I think that's somewhat comprehensive. At least for the set of operators we have right now. We probably want to handle the double negative case. Yeah, I'm gonna head to the bathroom real quick though. I'll be right back. It should be a second. Alright, I'm back. Hopefully everyone's still alive. Shoop. Okay. Yippee. As we were working on, I think that's all of the cases that I want to handle. Maybe there is like the double negative case, but I don't have like an intrinsic that represents unary ops in this, so that might be a little bit difficult to implement. Let's see if there's anything else. Strength reduction, I think we could do some of this, I think. Maybe we could make a like strength reduction pass as well. Yeah, we could probably try that. But I kind of like keeping the multiplies around almost, because that's how our tiles are generated for, what's it called? That's how we generate LEAs. We generate off of those. So it might be a little bit awkward. Yeah. So you have those. Yeah, there's a lot of simplification stuff we can do. Yeah, wow. Let's see. Yeah, this is crazy work. Addressing, okay, that's like a whole nother can of worms. I think this might be a good intermediate point to be at though. Yeah, let's format. Let's just see what happens. I'm very happy with this infrastructure. This might fail some tests. I hope it fails some tests, because that means something's changed. But it's not looking like it's changing anything. So let's write a quick test, or modify a test real quick. So let's give it, what, inst combine? Yeah, so let's do int, what do we call this? Maybe simplify instead? Simplify. Int I. Okay, so we can do what? What do we do with this? Int I, or const, or 1 equals 1. Or actually we could do, so we can do I plus 0. We can do 0 plus I. Let's see if this even like works properly. What is wrong here? Is this infiniting? I think it's infiniting. Okay, so these are changed, yeah. Yeah, that's not ideal. Okay, so we want to replace the uses and then erase uses, okay. So we want that. I accept UV. Except that doesn't exist yet. What's up, Romy? Let's actually just write all of this out real quick. We'll do those for now. We need our Where's our erase uses? Where'd that go? Okay, so that does exist. What's wrong? Oh, ref. What ID is this? This is Neovim. I love Neovim. Oh, I use Neovim, by the way. But, like, actually, I do use Neovim, by the way. Is there anything else I need to do to drop something? Yeah, we need to push back. Okay. Yeah, so we can throw this into here as well. Yeah, so this is looking very boilerplate as well. Okay, well, that's fine, I guess. Okay, let's do that. And then we could do that, and we can do that. We're gonna need to clean this all up. But that's fine. We'll worry about that some other time. Make again. This shouldn't infinite. It's seg faults instead. Well, that's not ideal. Input call chain. Get value. Oh, we're returning after erasing, right? Let's combine 169. It's here. But we're returning true, so it shouldn't exist anymore. Or we should be done. Right? I don't know. We'll debug this next time. I'm kind of tired. So I think we've got a solid hour in. I think that's a reasonable pause. I'm not going to commit any of this because I don't feel like I want to commit broken code right now. But yeah, thank you all so much for showing up today. If you haven't already, like the stream and sub to the channel if you're new. Also, you should check out the description. My Discord is down there. It's a nice little community. Everyone's really chill. You should join that if you have not. Also, my GitHub sponsors is there if you want to give me money, I guess. And I have like socials there as well. Yeah, I'm gonna go enjoy my evening now. Take care, y'all. Take it easy, and I will see you all tomorrow.